I always think we have a deeper understanding of a concept when we think through it forwards and backwards. So in this video, we're going to be writing trigonometric functions from a graph. So let's write the equations of a sine and a cosine function that represent the given graph. Well, if I was given the choice, it would be no contest. I'd write a cosine here instead of a sine. And the reason that I know that I would prefer to write a cosine is because my graph does not start at the origin. All right? It doesn't pass through the origin, which sine does. Remember that cosine always starts with our a value. So I'm going to start by doing the cosine because that means that there's not going to be a phase shift. We can do it with sine. It's just going to involve a phase shift. So starting with the cosine graph, I'm going to start by looking for the middle line of my graph. See if there's been a vertical shift. And the halfway, the middle line of my graph, is right here on the x-axis. So that tells me there's no vertical shift. The a value of our graph is equal to the y value when x is equal to 0. So that happens right here. Where does cosine start? At -2. So that's our a value. We've established that this will not require a phase shift. So the only thing we need is the b value, right, the number that we have right in front of the x. And to find that, we're going to use the period of the graph. The period is how long it takes for the pattern to repeat. So that looks like 4 pi Our formula for period is 2 pi over b, and we know that the period is equal to 4 pi, so we can take those two and set them equal to each other and solve for b. Multiplying both sides by b, we get 2 pi is equal to 4 pi b, and then we'll divide by 4 pi. And that's going to give us a b value of 1/2. So that goes right here into our cosine equation. There it is. Y is equal to -2 cosine of 1/2 x. Now we want to write a sine function for this same graph. Well, the period and the amplitude are going to be similar. Well, the period will be exactly the same. The amplitude's the same, but the a value might differ. But remember that sine always goes through the origin, our parent sine function. And this one does not. Right? This has been slid over this way. For a sine that doesn't involve a phase shift, it would have been here. And then shifted over. So y equals, we can see that the amplitude is 2. And since we started at the origin and then went up first, that means that our 2 is going to be positive. So y equals positive 2 sine. Our pattern is still repeating every 4 pi. So the period here is the same as the period above, which means that our b value will be the same. But this one is going to have a phase shift. We have shifted, right, would have been at the origin, to the right pi. Well, since we're shifting to the right, I know it's going to be a minus in my equation. Our formula for phase shift is C over B. I know what B is. It's a half. So now I'm just going to take these two and set them equal to each other and solve for C. So I'm going to multiply both sides by a half. And that gives us pi over 2 is equal to C. So that's just going to go right here. So to write this graph as a sine equation, we would get y equals 2 sine of 1/2 x minus pi over 2. Now, your sine answer could vary, because maybe you shifted it a different direction, but this one I think is the most basic. But if I was given a choice, no question, I would have wrote it as a cosine because it wouldn't have involved a phase shift. So if you're given a choice, look, does it go through the origin? If so, use sine. If it doesn't, then use cosine. In the next one, we want to write the equation of either tangent or cotangent, not both. We'll just pick whichever one's easier, and write out the equation for it. Well, when I'm deciding whether I'm going to use tangent or cotangent, I usually look at the asymptotes. Because if I can avoid doing it with a phase shift, that would be my preference, because I think that that's the most work. So right now we have asymptotes at pi over 2 and then another one here at 0. So we want to think, well, where are the asymptotes in tangent versus the asymptotes for cotangent? Cotangent has an asymptote at 0, while tangent has an actual value of 0 at 0. And if you ever forget, you can just go back to the unit circle. And just look, here at 1, this is the point 1, 0. Cotangent is going to be x over y, and when the 0's in the bottom, it's undefined. Tangent is y over x. 0 over 1 is just 0. So you can use that to help you if you don't remember where the asymptotes are for tangent versus cotangent parent functions. So I would definitely write this as a cotangent, so I don't have to do a phase shift. Next, I would look for the center line. And the center line's happening at the third point. Usually with tangent and cotangent, they're going to give us 2 asymptotes and 3 points. So here's our middle point. And our middle point is not on the x-axis. It is down 1. So down 1 tells us that we're going to have a minus 1 on the outside of our function. To figure out the A value, you want to look at the distance between your middle point and then one of the other points. How far down is the next one? Well, that's down only 1, right? And same thing here. It's only a difference of 1, so that tells us that our A value is going to be 1. The last thing we need is the B value that goes inside our parentheses. And we get that from the period. Looking at our graph, right, our period is going to be the distance in between our asymptotes. And that's looking to be pi over 2. For cotangent, the period is pi over b. All right, for sine and cosine, it's 2 pi over b. But for tangent and cotangent, it's just 1 pi over b. And we said that our period is pi over 2, so we're just going to put those equal to each other and solve for b. I'm going to cross multiply, so it's going to give me b times pi equals 2 pi, and then divide by pi. It's going to give us b is equal to 2. So the graph of this, the equation for the graph to the left is going to be y equals 1 times cotangent of 2x minus 1. And lastly, I want to do one that's secant or cosecant. Well, I always start by flipping my graph back. Right? The last move for secant and cosecant is always we flip it. So I like to flip it back to start. I also want to identify the center line. I guess I'd do the center line first. Right? The center line is going to be right here because, right, we need this distance to be the same. So that's got to be the center line. And I'm seeing that the center line is not on the x-axis, so I'm already thinking there's got to be some kind of vertical shift. But I don't know which function it is yet, sine or cosine. Which would tell me if it's secant or cosecant. So I'm gonna flip it back and see what it looks like. All right, so if we flip it back, it looks like this. And if I move my middle line down, it's gonna look like this. So I'm looking at that green to decide, is that sine or cosine? Well, it doesn't go through the origin, so I can't write that as sine unless I do a phase shift, and nobody wants to do that if they don't have to. So I'm looking at this green, and I'm definitely saying, all right, that's looking like cosine because it starts up here at 1. So this is going to be secant. We've already mentioned that the graph has shifted up 1 because our center line is not on the x-axis, so I know that I have a +1 on the outside. We'll decide our A value based off of the amplitude of that green cosine graph. Our amplitude, our A value, is like half the distance from the max point and the min point, but I like to just look at our center line and say, all right, how far from the center line? That's 1 from the center line, so that's going to be an amplitude of 1. Since our cosine value is at positive 1 when x is 0, then I know that that a has to be a positive 1. So positive 1 out in front. And now the only thing we need to deal with is the b value inside here. We're going to get that from the period. Our period goes from here to here, but be careful, right? Because I got like negative pi over 2 to the left and then positive 3 pi over 2 to the right. So this is actually a period of 2 pi. Right? Because I got half a pi this way and then 3/2 a pi that way. So together, that's 4 half a pi's or just 2 pi. Oh, the period, since this is based off of a cosine function, our formula is 2 pi over b. And we know that our period is 2 pi. So putting these equal to each other, we can solve for b. I'll cross multiply and divide. And we get b to be 1. So the equation for this graph is going to be y equals 1 times secant of 1x plus 1. You can expect on the exam to see ones going both directions, where I give you the equation and ask you to graph, or I give you the graph and ask for the equation.